Okay, I just wanted to very quickly go over what you need to know for the exam. It will be Thursday the 8th during class, so 9:30 to 10:45. You can use your notes, you can use your e-textbook, you can use your computer or, iPad, whatever it is that you use. But your work is going to be submitted on paper. Now, on that, I need you to write only on the front side of the exam. Anything that's on the back side is not going to get scanned to me. I will be in Austin that day, and so someone else will be giving the exam, and they're going to scan your work to me. They're going to scan only the front pages. So seriously, if you write it on the back, you can do that for your own notes, but it's not going to be what I get to grade. There'll be approximately 10 questions. I'm not sure exactly, maybe 8 or 9, but on the order of 10. Some of them may be related to each other, so if it's 10, it will probably be something where like part 1 of a calculation or a diagram or something that you're looking at, and part 2 asks you to do something with that information. Usually on those, I give you something in case you missed the first part, how to get started on the next part using an incorrect answer to the other part. But it does make it so that you can take all the questions independently. Don't worry about them building on each other. Sometimes people run into problems like with the book if you don't have it downloaded to your machine during the exam. So I would make sure that those really important things out of the book you have available to you in some other form. Of course, because we have an e-textbook, that means I need to let you use the computer during the exam, but we will not, for this exam, be using either CapCost or ChemCAD. I may ask you about, I ignore that next sentence there. I may ask you to interpret some information that I did in one of those, and I give you a printout or a picture of it, but I'm not going to ask you to use the tools, and so obviously you don't need to submit files if you didn't use the tools. So the things that you need to know how to do: reading and understanding those key types of diagrams that we've been talking about that represent our chemical processes, and of course being able to trace chemicals through those. Do an overall material balance, just those general things that we did that first week. You also need to, and I think this was chapter 5 in our book, maybe it was 6, develop a set of questions to ask as you make preliminary decisions about process alternatives, and recognize when you have unusual operating conditions and identify whether or not they're justified. Now, some of those things are a little bit tricky, like some of the stuff about reactors. We'll learn more about that, but it won't be on the exam. But some kind of key things like high pressures or high temperatures or those various things that were in that process conditions matrix. Those are the kinds of questions you should be asking yourself, as well as questions about safety and economics. So then we moved into studying a little bit of economics, and so we were working on capital costs. That will be the largest portion of this exam. So you need to know how those estimates relate to the actual expected cost for the different categories of estimates related to how much effort we've put into our design at that point. We should be able to estimate equipment costs using data. So if we had a previous purchase, I can adjust for size or time or both to get an estimate today. And then also doing these module factors that are using kind of a conglomeration of data. Those you should be able to do by hand with Appendix A or using CapCost, but again, I'm not going to ask you to use CapCost on this exam, but if I were to give you like one of those screens, can you find and read the information for it? As far as safety, so far what we've done is read safety data sheets, and if I gave you a safety data sheet, you should be able to tell me important things about the chemicals, how it should be handled, whether or not it's something you should be concerned about, etc. Your homework for ChemCAD this week is about thermodynamic models, and so selecting those best thermodynamic models is going to give us our best physical or best mathematical representation of physical data. And so that's very important. So what we're going to be doing is we're going to take the recommendations that ChemCAD makes based on type of chemical, temperatures, pressures, etc. And then we are going to compare that data to our physical data that we were able to find from literature, okay? And know that maybe I need to add binary interaction parameters or something like that, or maybe choose a different package. And then as far as the project, I will continually test you guys on the project as we go, in addition to the reports and just doing the project. But essentially what you need to always know when we get to one of these exams is, what has your team been doing so far? So what alternatives have you looked at? What are the scary things that you guys have found so far about these models that maybe you are concerned about whether or not this is going to work so well, etc. Whatever the status is at that time is fair game for me to ask you. So this would be the material in reports 1 and 2. Okay? So that concludes the review. I will see you in class on Thursday. Bye.